In the previous video, we talked about how to index into a cell array. We talked about two different kinds of indexing, right? Content indexing and cell indexing. And then we looked at how we can use cell arrays to solve various kinds of problems, right? We looked at some use cases for cell arrays. One of the things that I forgot to do is to actually, there's another quite important application of cell arrays, which is for storing a collection of strings, basically, right? Um, uh, String arrays, storing string arrays in cell arrays, right? And this is an example that's given on our textbook. It's on page 143 of our textbook. That's an engineer's guide to Matlab, right? So we have looked at how to actually use the char function to actually construct a matrix of characters, right? So suppose we have, say, a very long character, a very long string application, apple, friend, apply, and then find, right? That kind of thing. Then it's gonna construct a matrix, a 5 by 11 char matrix, right? And you are gonna get lots of these kind of trailing blanks after those shorter words. So every word is gonna be padded using trailing blanks to match the length of the longest string, right? So if you have like one string that's kind of a lot longer than all the rest of the strings, then you're gonna waste lots of memory to just store those trailing blanks, and that's not exactly uh, that's not a good application. That's not a good example, right? So uh, so if you store those strings into a cell array, you won't have this kind of problems, right? So let's look at how we can actually do that. So we construct a cell array that's called words, right? And then we put the words inside of it. Applications, right? Application, maybe to be consistent with the textbook. Apple, friend, and then apply, and then so it's more like a row vector, right? So because every element is separated using a comma, right? So it's just got one row and then 1, 2, 3, 4, 5 columns, right? So that's our cell array, right? And then once you have this particular cell, let's hold down the control key and press enter, and then we will be able to actually examine words, right? Words. Maybe I should clear it and then hold down control key and then execute it. Now it's telling us words is a 1 by 5 cell, right? If we want to look at the contents of words, then we're gonna see the 5 words, and then they don't have trailing spaces, right? If you compare it with this particular thing, right? Maybe you are gonna say that it's a row vector, it's a column, not column vector. So if you want to get the column vector, all we have to do is to actually transpose it, right? We just transpose this row vector, then we're gonna get the column vector. But you can sort of see that there's no trailing blanks after those shorter strings, right? So it's not gonna waste lots of blank spaces not lots of memory to store those blank spaces, right? So once you got the cell array of the strings, one of the things that people may want to do is to actually sort it, right? Sort it in terms of the alphabetic order, right? So let's word sort to be consistent with the textbook, and then we can use the Matlab sort function, right? And then if we want to return a column cell array, then we can just transpose the output of the sort function, and then assign it back to word sort, right? So if we hold down the control key and press enter, we should be able to actually see word sort. So that's the 5 words sorted in the alphabetical order. Right? And again, you don't see blank spaces, trailing blanks. Right? Sort can be used for sorting not just the characters, right? It can also be used for sorting numerical numbers, any kind of numerical numbers, if you want to do any kind of sorting. Right? Um, but suppose you have actually you actually would prefer to actually construct a char array for some kind of a some kind of a reason, right? So there might be use cases for us to actually. So let's look at another. Uh, so if you have constructed a char array, if you want to convert it into a cell array, right? So here we are just typing up this cell array, the content of the cell array by putting those words in there, right? Suppose you have a char array that's constructed already by, for example, somebody else, right? You want to convert it into a cell array. So how can you actually do that? So suppose we have a char array, let's say C A R array equals 2. So I'm deviating slightly from the example in the textbook because I want to show you the differences, right? Application, Apple, friend, apply, right? So hold down the control key and then press. So C array is supposed to be a char matrix, right? That's like 5 rows, 11 columns. Right? So every word is padded with every short word is padded with trailing blanks. Right? And then once we have that, we can actually convert it into a cell array. So suppose we do another words equals to, we have a function that's called a cell str, and then this particular function takes a char array or char matrix as the input, and then it's going to remove all the trailing blanks. Right, so hold down the control key, and then if we look at the words, it should be identical to before. So all the trailing blanks have disappeared. So that's a quite convenient function for us to actually reformat those strings constructed by using a char function or inside of a char matrix into a cell array, right? And then at this point we can still sort it, right? Word sort equals to sort uh, words, right? But this time we don't really have to transpose the the, the output of the sort because it's already sorted. So let's hold down the control key and press enter, and then word sort. That should be sorted strings, the 5 sorted strings, right? Um, so so if you do have to actually sort a char matrix instead of a cell array for strings, right? In some applications you may have to actually sort a char array, right? So how can you actually do that, right? So C array is like that, right? Um, and then we have another function that's called sort rows. So if you do sort rows and then give it a char array, then it's gonna sort all the char array with all the blank spaces as some kind of a sort of accounted for, right? So the result here is actually the same as a word sort, right? Except that you're actually sorting uh, a char matrix with all the blank spaces, all the trailing blanks, right? So that's still another different way for sorting characters, right? But this time it's actually sorting uh, sort equals to sort rows with the plural, right? Sort rows, and then let's get a C array. Hold down the control key, and then C array sort is supposed to give us the sorted char matrix, basically, right? So this is sort of everything I can think of about the cell arrays. Of course, you can use cell arrays to store many very complicated data structures, right? It's not just limited to the examples I have shown. Right? You can think of your own applications. Some people use cell arrays to store huge tables, right, with mixed data types. Right? At the beginning of the semester, we were dealing with car data, right? Some of the columns of the table was manufacturer, that's like a text string, right? Some of the columns are like Boolean, categorical, if it's a car or truck, if it's on highway or on city roads, right? So, and some of them are actually numbers, right? For example, MPG, and then CO2 emission, that kind of thing, right? Um, and the cell array is one of those data structures provided by the import wizard, right? The import wizard. So we can actually use cell arrays to store very large tables. Um, we, uh, Let me see if I can actually do something about it. Let's see if we can open. Let's open. I apologize for the waiting. It's a very slow computer. I should just okay. So it's um, so you can sort of see here the output type. The default is table, right? Let me see if the cell array, right? Cell array can also be used for storing the entire table, right? Right. String array, numerical matrix, column vectors, table. We haven't actually talked about the table data structure in Matlab, right? Table is also a composite data structure that allows you to store um, this kind of a table, right? But cell array is one of those data structures that we can use to store this kind of car table. Suppose I import this thing. Let me give it a name. Can I specify a name? I suppose it doesn't matter. It's just the import on selection. So okay, so it's called DAT, I think, right? So let's close. So now it's got the entire car table has been loaded into this particular data structure that's got. So we have like 2,337 cars, right? And then each car has like 24 columns. So the dimension of the cell array is like 2337 times 24, right? So if you just double click on it, you should open a variable view to allow us to actually examine the content of the cell array. For some reason, it's not opening. Uh, right. Also, all those data are in there, right? Some of them are stored as numbers, some of them are stored as characters, that kind of thing. But every element has been wrapped inside of a cell, and then all those cells organized into this particular cell array with this kind of dimension, right? So you can use cell arrays to store huge tables, right? Okay, that's cell operations, right? Let's save it. That's cell operations, right? That's one of the files that we have created today. And then let's try to write another script. And in this script, we're going to introduce something that's called a struct. It's a slow computer, so let me sort of clear all and then COC. So let me just free up all the memory. So MATLAB struct is also a composite data type, right? It's just like uh, this kind of, and it also allows you to actually store heterogeneous types of data. So it doesn't have to be uniform like a matrix or vectors, right? It can be heterogeneous just like serial arrays, right? But it gives you a better naming convention. So serial arrays basically takes indexes, right? So you have to, if you want to retrieve the content, you have to give it some numbers as index, right? But a struct actually allows you to define certain fields. A field actually has name. So later on, if you want to retrieve the content of a particular field, you can just use the name of the field instead of using those indexes to actually access the content, right? Um, so let's call it a uh, struct operations, right? And then creating a structure. Struct is the short name for structure, right? You can think of it. You can think of a cell array as a large container, and then every smaller container inside of it is something that's called a cell, and every cell has a coordinate, right? And then the coordinate is basically its index. Depending upon how many dimensions you have, you're gonna have multiple number of indexes, right? So if it's a two-dimensional cell array, then you're gonna have two indexes, right? But if it's a three-dimensional cell array, you're gonna have three indexes, right? So the index is basically the the approach for you to actually access the different smaller containers inside of the cell array. Structure is slightly different. It allows you to define fields. So suppose I define a structure that's called S. Right. S is my struct. S is my struct. And suppose I want to have a smaller container inside of S, and this smaller container is called A. It's called A, right? And A is inside of S. So how do I actually create this kind of association, right? I use the dot. Right? So dot means what? Dot means A is a smaller container that's inside of the S, the big container, right? So in this case, we're calling it fields. So structures with scalar. We're gonna start with scalar fields, and then we're gonna expand to different kinds of fields, right? So now the field name is A. It's called a field, right? The field name is A, and then the struct name, the name of the structure is called S, right? So S is the name of the large container, and A, which is called a field name, is the smaller container that's nested inside of the big container, right? So suppose we assign a number to it, say get it like 1, right? And then suppose we want to create another small field, smaller container field called B, right? And then S dot C equals to 3. Right? So if you have used object-oriented programming languages like C++ or Java, this kind of dot may look familiar to you, right? In C++ or Java, this dot allows you to access members of a particular structure, whether data members um, or function members or method members, right? Methods. Um, let's run it. And then it's gonna ask us to pick a name. Let's call it struct operations. So that's like the simplest. That's like the simplest struct, right? It's got like 3 different fields, and then once it's created, we're gonna see in the workspace S is a 1-by-1 struct. Why it's called a 1-by-1 struct? Because S itself is a scalar struct, right? It's not an array. It's not an array of structures. It's not an array of structs. It's just a single one, single struct, right? That's the reason why it's called it's 1-by-1. It doesn't really matter how many fields are inside of it. We have 3 fields inside of it, right? but the struct itself is like a one thing. It's not an array or anything, right? So that's one of the ways for creating the different fields, and also creating the uh, creating a creating the fields together with the structure, right? So if you if you create the fields in this particular way, S MATLAB is gonna recognize that you want to create the structure S together with all those fields, right? So the creation of the struct S is implied. It's gonna automatically create the struct and then put the fields in, right? And there's another way of creating a struct, which is by calling the struct function, right? When we were creating cell arrays, we also looked at another function called cell, right? The cell function also allows you to actually create a cell array. Here, the struct function allows you to create the structure, right? And then what's gonna be the input to the struct function, right? It's gonna be the name of the field followed by the value for that particular field, right? So if suppose we want to sort of duplicate the same structure here, right? The name of the field, the first field is A, right? So the name of the field has to be a string, right? It has to be, the name of the field must be specified as a string. If you forget about the single quote, then it's not gonna work, right? Because we don't have a variable that's called A that's defining our workspace, and A, even if you have A may not be a string, right? So don't forget about the single quote, the apostrophe or something, right? Which means that this is actually a string, and the content of the string is supposed to be the name of the field, right? And then the next one is supposed to be the value for that particular field, say 1, right? And suppose if you have multiple fields, you just repeat the same pattern, right? It's more or less like a key value pairs, right? The name of the field is the key, and then the value is the value for the corresponding key, and then the second field is called B, right? And then the value is 2, and then C, the value is 3, right? So suppose we run it. So S is gonna be this kind of struct with the A, B, C as fields. So that's an alternative way for creating a struct. Okay. So this is a structure with scalar fields. You are just putting a number into it, right? So, but it doesn't have to be. It doesn't have to be. You can create a structures with non-scalar fields, right? So suppose S dot A now equals to 1. Let's give it a vector 1, 2, 3, 4, right? So it's just like cell array. You can actually store anything, pretty much anything, into a field of a particular struct. Right. Here we are assigning a vector to the field A of the struct S. Right. S dot B, let's assign a string to it. Right. And then S dot C, let's assign a matrix to it, or zeros. Right. So now let's run it. So now if I want to look at the S, A is going to be 1, 2, 3, 4, right? And then B is going to be A, B, C. C is a 3 by 3 double. So if I want to look at what's actually the content of C, I can type S.C in the command window, and then it's going to display the content of the struct, the content of the matrix, right? So zeros. So the field of a particular scalar can be anything, right? It could be another cell array, for example, right? Or could be another struct, right? It doesn't really matter. It can be used for storing pretty much anything. And again, if we wanna use the struct function to create the same struct, we can do that, right? And then the field name A, right? And then followed by the content 2, 3, 4. Not exact content, value. I should say value, right? B, and then A, B, C, Don't confuse. Don't confuse. Don't get confused. So this is the field name, which is a string, right? But the value for that particular field is also a string, right? So this is not a field name. It's the value of this particular field. And then C is the ROS3, right? So that's the alternative way for creating a struct that has non-scalar fields, right? Um, so even though the fields can be vectors, can be matrices, if you look at the dimension of S, it's always 1 by 1, right? Suppose we want to create an array of structs, right? This is a scalar struct. It's just a one struct. Suppose we want to sort of create an array of structs, right? So how are we going to do that, right? Suppose we just want to create an array of two structures. So this is a fundamentally different concept from a structure that contains values as fields, as field values, right? So here the value of the field is an array, right? It's a vector. But now we're trying to create an array of structs, right? Array of structures. So how do we actually do that? So S, right? S, let's still call it S as the array of the structure, as a array of structures. So we're going to assign to the first element of this array of structures, right? And then the first element is going to have a field name that's called A, right? And then let's give it some arbitrary content, arbitrary numbers, right? Arbitrary value. And then S2, which means what? S2 means we are accessing the second element in our array of structs, right? And this second element also has a field name that's called A, right? But this time we're going to assign something else to it. It's going to be a completely different type. Let's say ABC. It's not even a vector. It's not even a number, right? But you can do that. It's not a problem, right? And then suppose every element inside of the struct, so let's create another field, right? So S1, again we're creating another field for the first element of the structure array, and then the name of the field is called B. Right. Let's call it XYZ. And then S2B, S2.B equals to say pi, right? Some numeric number. Right. And then S1.C. Let's give it some matrix, say an identity matrix with 3 rows and 3 columns. S2.C is gonna equal to say 1 to 5, and then transpose it. Right. Right. So now let's run it. And then as soon as we finish running it, you can sort of see that S now is becoming a 1 by 2 struct, right? It's not a 1 by 1 struct anymore. It's a 1 by 2 struct. The reason is because S is an array of structs, right? It's got 2 elements inside of it. The first element is a struct. The second element is also a struct, right? And all those elements actually has 3 different fields, A, B, and C, right? Both elements actually. So if you look at S, it's going to tell you that it's a 1 by 2 struct array with fields A, B, and C, right? So if you do S1, then it's going to display the content or the different fields that belongs to the first element of the struct array, right? And then if you do S2, then it's going to display the content of the fields, the field values for the second element of the structure array, right? So if you type S.A without quantifying the element, that's gonna display all the fields, all the A fields that belongs to this S struct array, right? So the first element is gonna have a field, right? That's 135, 135, and then the second element of the struct array is also gonna have the A field, which has a value of ABC, and that's why you see ABC, right? So if you do S dot B, then it's gonna display the B fields for the two elements inside of the S struct array, right? S dot C. Um, and of course, for this kind of a struct array, you can also use the struct function to actually create it, right? It doesn't have to be uh, you don't really have to actually write so many lines, right? Let's write the alternative way. The alternative way is by using the struct function, right? By using the struct function. So let's create another struct array. Let's call it SS, right? SS is gonna equal to struct, right? And then key value pairs, right? What's gonna be the key? A is the key, first key, right? The name of the first field, right? And then what's gonna be the value? But this time it's not one value anymore, right? It's actually two values, right? So because for the first element, the value is 135, a vector, and for the second element, it's a string ABC, right? So how do we actually assign these two different values to the A field, right? For the two different elements of the struct array, we use the cell array as the second argument, right? And this cell array must contain the content, the value for field A, right? The value for field A is 135 for the first element of the struct array, right? And then the second value, the value for the A field of the second element is ABC, right? ABC. So that's the A field. And then what about the B field? The B field is it's still gonna be a cell array, right? XYZ, right? And then pi, right? And then the C field, EYE3, and then 1 to 5 transpose, right? So that's gonna be SS. And SS actually is gonna have exactly the same content as S, right? So this is actually assigning a vector, right? Suppose I want to change this one to a cell array, right? Suppose that's gonna be different, right? So let's create another one. Let's say H. H is gonna equal to, let me just copy this thing over, and then I'll just change the square bracket to curly brackets, right? And then let's execute it. Now what's gonna be H, right? What's gonna be H? H dot A, right? H dot A so H is gonna be 1/2 also, right? But for the first element, the A field is not gonna be, the value for the A field is not gonna be a vector anymore. It's a 1/3 cell array, right? So you do have to be actually careful about the curly brackets, right? So if you want the value to be a vector, make sure that you use square brackets. But if you want to use a cell array, you want the value to be cell array, to make sure that you use curly brackets. Don't confuse the outer curly brackets with the inner curly brackets, right? The outer curly brackets, this thing, is used for grouping together the different values for the different elements of the struct array for the same field name A, right? So it's the A field for different elements of the struct array H, right? So we do need to be quite careful. We do need to be quite careful, right? Um, so now let's look at nested structures. Right. Now let's look at nested structures. Maybe it's a good idea to clear all the previous variables. Right. So we're gonna try to create two structs. One is called S. We're gonna create S is still gonna be a struct array. It's not a struct. It's a struct array, right? And then we're gonna create another struct that's called H. Right? So H is gonna have two fields. H dot F1 is gonna equal to it's a cell array A, B, and then C. Right? So H is the F1 field of H struct is going to be a cell array with three elements A, B, and C. Right? And then H dot F2, that's the F2 field of H is going to be a vector 2, 4, 6. Right? Suppose, right? Doesn't matter. Right? And then let's create a struct array that's called S. S1 dot A is going to equal to 1, 2, 3, a vector. And then S2 dot A is going to equal to, that's just the character A. That's just the character A, right? And then S1 dot B, the B field for S1 is going to, let's give it a character J. And then S2 dot B is going to equal to the number pi, right? And then S1 dot C is going to equal to what? S1 dot C is, let's assign H to it, right? So H is a struct, don't forget, right? It's a struct with two fields, F1 and F2, right? And now we are assigning this H struct to the C field of the first element of the struct array S. And then S2 dot C is going to equal to a vector, right? So let's just give it a run and see. Let's hold down the control key and press enter just to run this particular section, right? So now we have H and S, these two structs, right? These two structs. So S dot C. This is expected, right? 1, 2, 3, 4, 5, and then S dot C. But 1, 2, 3, 4, 5. This vector is just for the second element of S, right? For the first element, it's going to be a struct. Right? It's a struct with two fields, F1 and F2, right? And then F1 is going to have this thing. It's a cell array as the value, and F2 is going to have this vector as its value, right? So if we want to do S1.C, we're going to get this struct. We're going to get this struct, right? And then S1.C, if we want to access the first field, F1, we have to do another dot F1, right? That's going to give us the cell array. Right? And suppose we want to get the content of the second element, right? And then that's going to give us B. So if you look at this particular command that I have typed, it looks really kind of difficult to understand, right? It's kind of encryptic, right? But if you understand what the structure is actually, what's actually the nested structure of this particular thing, you're gonna understand what it means, right? So if you read this particular command from left to right, S is the name of the struct array, And then smooth parenthesis 1 is going to allow us to actually access the first element of that particular struct array. Right. The first element of that particular struct array is a struct. Right. It's a struct. So that struct is going to have fields. Right. And in fact, we have like A, B, C, 3 fields. Right. And then here we are dot C just means that we want to access the C field of this particular struct. Right. So once we get access to the C field, we can access we, the value for the C field for S1 is actually a struct, right? And that struct has actually two fields. One is called F1, the other one is called F2, right? And then if we want to access the F1 field, we use the dot again, right? This dot F1 means I want to access the F1 field of this whole thing, this whole struct, right? And then that's going to give us a cell array. If I want to do a content indexing into that particular cell array, I do this thing, curly brackets 2. Right. So once we have this kind of nested structures, the way for retrieving the content could be quite complicated, right? And in practice, you don't really want to sort of do this kind of thing. You want to avoid doing this kind of thing. You want to come up with a data structure that's as straightforward as possible. And if you would like to actually reduce the amount of typing, you can still use the struct function to actually construct these two structs, right? So h can equal to struct, right? So the first field is called f1, right? And then the content is going to be what? Here is something that we have to be careful about. Right? The content is going to be a cell array. So here you might be confused, right? You might be confused about why do we want to actually use two curly brackets here, right? It's H is not a struct array, right? H is just a scalar struct. It's a 1-by-1 struct, right? So why do I have to actually enclose the value of the field inside of the curly brackets, right? The thing is that if you actually remove the outer brackets, if you actually remove the outer curly brackets, if you do it like that, Matlab is not going to automatically know that you're assigning a cell array to the field f1 for a scalar struct. It's not going to know that, right? As soon as Matlab sees these curly brackets, it's going to think about constructing an array of structures, right? So what it's going to do is that it's going to create a struct array that's called H, and it's going to have 3 elements, H1, H2, and H3 inside of that struct array. And each one of them is going to have a field called F1. And then the first element, the H1 is going to, the value for the field F1, for the first element H, inside of H, is going to have a value of A. Right? And then for the second element, its F1 field is going to have a value of B. And then for the third element, its F1 field is going to have a value of C. So in this case, you have to use a curly brackets, an outer curly brackets, to make sure that the value of the F1 field is indeed a cell array, right? And then for the F2 field, it's going to be a lot easier, right? So it's just what's actually the value? It's 246, right? 246. Right, because it's not a cell array, so it's just a vector, so you don't really have to encapsulate, so enclose everything inside of curly brackets. Right. So that's going to be our H, and then S is going to equal to struct. Right, and then it's going to have a field of A, and then, but this time S is a struct array, right? So 1, 2, 3. That's the value for the A field for the first element, and then A is the value for the second element, right? Character A, and then for the field B, it's again gonna have 2 values. One is J, the other one is pi. And then for the C field, the first value is going to be h, that's a struct, right? And then the second one is 1 to 5, the second value transposed, right? And then let's run it again, and then I should be able to actually have h and s just like before, right? So that's my h, right? And then that's my s plus c. Let me just look at the c, right?